Today's lesson is on translations. A translation is a rigid motion. A rigid motion is an isometry. It does not change the size or the shape. A translation is an isometry that slides, so it's a slide, all points of a figure the same distance in the same direction. So this is an example of a translation right here. Each point of the figure has been slid from this point in the same distance in the same direction to this point over here. Okay? That's a translation. And when we say that it's translated along this vector here. So this vector is this same distance as this, is the same distance as in this direction, so at this angle. Okay? This is also a translation upon that vector. Each corner has been slid along that vector. And if you notice that each of the lines that I drew here are all parallel to each other. So they're going to be translated in a parallel direction, the same direction in the same distance. Over here, this is not a translation. There is no slide. It looks like a turn. A translation can also be described as a transformation along a vector. So that's what I was talking about here, a vector. It looks like a ray, such that the segment joining a point and its image has the same length as the vector and is parallel to the vector. So these are the parallel to the vector. A vector has quantity and magnitude. Is a quantity with magnitude and direction. Okay, so it's a quantity with magnitude and direction. So magnitude is length or distance, and direction. There are two different ways to write a translation, two different kinds of notation for translations. The first notation is called component form, and this is the vector notation or the component notation. It is not a typo that this has less than or greater than looking arrows here instead of some parentheses. This indicates that it's a vector. In A would be your left and right direction, and B would be your up and down direction. Now, this is the same notation, it represents the same thing. A component form and a coordinate notation represent the same thing. This is the notation we're kind of used to. This is what we used for reflections. A coordinate maps to the coordinate plus whatever left and right direction we did, plus the y coordinate with whatever up and down direction. So x direction is right and left, and y direction is up and down. Just like the coordinate plane. X is back and forth, y is up and down. If you want to translate in the coordinate plane, if you want to just translate horizontally, if we're translating horizontally, all we're moving is the x value. From here to here plus some value, or backwards would be subtracting. So if you're going right, you're going to add a value. If you're going left, it's going to be a negative value. So the horizontal translation along a vector would be the x, whatever x change you make, and 0 for the y, because you don't go up and down. In vertical, you don't go left and right, you just go up and down. So it'd be 0, and whatever amount that you move up or down is your b, or your y direction. If you want to do both, if you want to both change the x and the y direction, you're going to add an a or add a b, or add a positive or a negative number. If it's a positive number, you're going to go right. If it's a negative number, you're going to go left. If your y is a positive number, you're going to go up. If y is a negative number, you're going to go down. Okay, so these are the different ways and different notations. Here's vector or component notation, and here's coordinate notation. If you want to translate a, let's say here, it says I want you to translate a triangle, JKL, so this is J, this is K, and this is L. If you want to translate that triangle along the vector -4, 2, that's the same thing as taking the image and subtracting 4 for the x direction and adding 2 for the y direction. So you're going to go left 4, up 2. So you're going to take your original 0, 1 for your J. You're going to go left 4, 1, 2, 3, 4, and up 2, up 2. So that's where you get your J prime at -4, 3. So for K, you're going to go left 4, 1, 2, 3, 4. You ended up at 0, and up 2, 1, 2. So you started at 2, you go up 2, so you end up at 4. So it's 0, 4. Okay, so L, you're going to go left 4, 1, 2, 3, 4, and up 2, 1, 2. So your L is going to be 3 minus 4 and -1 plus 2. 3 minus 4 is -1. -1 plus 2 is 1. That's translations using coordinate and component form. Remember, the x direction is left and right. The y direction is up and down. Thank you. See you tomorrow.